Good afternoon, Jan.
Michael, good afternoon.
How do you do, sir?
Doing well. What about you?
Fantastic. Yeah, just making sure that everything is set up properly. I'm thinking I'm going to try something a little bit different today with the OBS setup. Hopefully, we can fix that problem um, that was introduced when there was a Discord update that if something else covers up Discord, then it stops showing the videos. But that means that I can't grab the videos from underneath the window and show them on OBS. So I'm going to
Mm.
try sharing my applications not full screen. So there's still just a little bit of Discord around them. So there may be a little bit of tweaking of the of OBS during the stream, but we'll manage.
We'll see how that goes. I did saw your mail. Yeah,
Mm-hmm.
I responded to it.
Mm-hmm.
But then the next day became the next day became the next day.
Mm-hmm.
And in the end, yeah, this morning I say, okay, I don't care. Let's follow everything and get back to historical modeling because otherwise we will never get there.
Yeah.
So got a little bit progress. So yeah, didn't upload it yet.
Mm-hmm.
And you wrote that it would help you. So sorry for for that I didn't got to it. Um,
Yeah, I think your branch might be deviating uh, from what's in on the remote quite a bit. And
mhm,
yeah, if um, find a place that you'll be comfortable uploading that, then I should be able to help out with any merge conflicts
mm.
with changes that I made on my side.
Yeah, because it's two branches that are completely the different
Mm-hmm.
side. Let me show you the little bit things that I did this morning. Not much. Um,
Okay.
wait, yeah, here we are, not getting anywhere yet, but where was it? So the problem last time was that we were using, no, where is it? The SQL store here. Execute query 3, execute query raw. Up to now, we were using this execute query function
Mm-hmm.
where we had to give a type.
Yeah.
Yeah. And so that type, we don't know it because we can have multiple fact records
Mm-hmm.
and different field names. So we need to get rid of that. So what I did was made this one, execute query raw.
Okay. And that just
Difference is that
returns the column name and the value.
yeah. So it returns a list of immutable dictionaries with the column names and the values. Yeah,
Nice.
the replace is still in in place. I didn't change anything.
Yeah.
Um, the difference is that you have this extension method raw row, and if
Mm-hmm.
we go have a look here, um, that was the one that we used before.
Mm-hmm.
So if we just simplify it, we make it an immutable dictionary, and we just run through all the fields, all the columns. We get a column name, we get the value. Column text can work for every data type, so it just gets it
Okay.
back as a string, and I add it to that to the dictionary, and I
Yeah.
return it as a dictionary. So in this way, we can add it here to that
Yep.
list of immutable dictionaries, and then we get where. Yeah, so that's what I do here. The execute query tree.
Mm-hmm.
So it gives me back my data rows, which is actually that immutable list of. And then I was working on this one.
Mm-hmm.
and there I got not far yet. One
Yeah,
thing that is
but
strange is
that's
that he's telling me that this is an immutable, an enumerable of my immutable dictionaries. And he's telling me that there is
yeah. You
no
want
map.
select instead of map.
Is there no map in C sharp?
Nope. That's what the select means. Um, yeah, uh, it's map in
Between
every other system, but it's select in LINQ.
yeah, okay. There we go again.
Yeah.
um,
Okay.
so data row. That is my
Mm-hmm.
row. Then I got an aggregate here with my accumulator and my next field. And so I was mapping. I had a new result set fact. Why is it changing here? At once it becomes red.
Yeah, it's also complaining about the lambda syntax. I'm wondering, does aggregate need the starting value first? So you give it a.
It's one of the options. If wait, let me move that one here because I always have to look up everything.
Mhm.
Right, aggregate. Where did I get it? Um, there is one that starts with an initial seed. This one
Oh,
also. This one.
I think it's complaining that there's no return. So this is a lambda that doesn't actually return um, the accumulated facts.
Not yet.
Yeah.
Because if I look back to on the other side, I have the JavaScript code. So it's gonna return syntax with. We are just adding the fact.
Yeah, so I think it's acc.add, and then you can give it the label name and the fact that you just. Is it the label name?
Yeah, because because it.
Oh, that's right. Yeah, this version
No.
that just takes the lambda expects two elements from the list, and the type that it's going to return is the same as the element from the list. So, for example, integers. If you wanted to aggregate in some of the integers, well, the sum of two integers is just an integer, so that one works. And it doesn't need the seed because it just starts with the first two elements of the list. But in this case, what you're returning is not the same as the elements of the list. So you need to give
So
it a
I
seed
need.
in order to change the type.
Yeah. I will think about that
Yeah.
slowly.
Yeah.
I will work on that for next week.
Okay. Yeah, and
But
I
okay.
think what you're trying to build there is an immutable dictionary. So you can give it an empty
Yeah.
immutable dictionary to start with, and then accumulate each of the facts
There
or
an
result sets.
immutable dictionary dot empty.
Yeah, and that's where you need to tell it in uh, the generic parameters. So it's immutable dictionary of
Yeah.
string to result set
Okay.
fact. Yeah.
I
Yeah.
will get it. Yeah.
Nice. Excellent.
When I work too much a little bit in JavaScript, then in C sharp I'm completely lost. If I go to C sharp, then I'm lost in JavaScript.
Mm-hmm.
Uh, and if I don't do anything, I'm lost everywhere. But but okay, I looked at your code in JavaScript and I understood how it worked for a while, and then
Uh-huh.
I forgot it. Um, but okay, so we will get there. and then so we will get as output this result set 3.
Mm-hmm.
Yeah. So I'm not sure whether there is perhaps even a better method. So in the SQLite here, so I use this column text,
Mm-hmm.
but actually that's doing a conversion to string.
Yeah.
If it's an integer, it's converting to string.
Yeah, and the fact IDs are
Uh,
integers.
yeah.
But those are the only ones. The others are the hash and data. And
And
we're
they are both
getting
string.
we're getting data out as a JSON string.
Mm. So let's try that way and see,
Yeah.
because I can check the data type also, the original data type in SQLite, but also there you're never sure because it's a very loose typed database,
Mm-hmm.
and it may add more overhead than we are saving
Yeah.
by doing it this way. So let's
Yeah.
see.
And the other idea that I could think of would be to have a instead of execute SQL raw, have a method that knows specifically that it is returning um, results or fact result sets. So
Mm,
so it does that conversion that you're doing in a separate method. It would do that inside of the execute.
and that it knows, for example, the first column must
Yeah.
be the hash. The second column must be the ID, so an integer.
Yeah. Yeah.
Yeah, but I'm not sure if I just walk through the columns like I do
Mm-hmm.
here, whether I always get them in the same sequence. Probably yes, but I haven't looked it up.
Yeah. I think that is a guarantee. Um,
It would
yeah.
surprise me if it's not the case, but
Mm-hmm.
um, I thought, okay, this this is the fastest way.
Uh-huh.
This is gonna give me some results by 3 o'clock when we start.
Yep.
So I say, okay,
Exactly. That's
how do they do it here? No, in the long one here. So
uh-huh.
what can I throw away to get what I need?
Yeah.
Uh,
Yeah, what they're doing in the generic one is reflection. So
yeah.
runtime, that one is going to be the absolute slowest. Um,
Mhm.
so so even though you're converting to strings and then maybe later converting back to integers, it's probably going to be faster runtime than the generic. And
Yeah.
then the idea of having the function know what the return type is, that's going to perhaps speed up the runtime a little bit more, but it also makes it less reusable. So
Yeah.
when you do the feed queries, you'll have to write another function. Whereas with this one, you can keep the same function.
Mm. Yeah. We will start with this.
Yeah.
Let's get the rest working first before we save some milliseconds.
Yep. That's the most important thing.
Mhm.
Exactly.
Good.
Excellent.
On your side, you're still using the same data types, the result set 3 and the SQL query 3,
Yes, I
which
haven't
I
changed that on
didn't.
you this week.
Okay.
No
No,
guarantees next week, but
because I didn't look it up. I didn't go to GitHub. I say, okay, let's get this done first.
mm-hmm. Yep, very nice. Well, I do have some changes that are not only available in GitHub but also in NuGet. So, published a new version um, of the library, and so these fix a bug that I found while I was testing the SQL generator.
Okay.
So when we went from 0.3 since the 0.3 release, I had rewritten the SQL the LINQ processor, and simplified it quite a bit. And then, as I was testing things out, I realized there was a case, actually a pretty common case, that for some reason I hadn't tested, and it was generating an incorrect specification. So I said, okay, let's do a refactor so that we can simplify things, find that bug, and in so doing, I even unlocked a pretty cool new feature. So let's try a share and see if this is going to work, and I can show you that new feature. Okay, sharing the screen, and then, all right, the videos are still working, so now I should be able to put us in the corner. Excellent. All right, and let me do a little bit of tweaking on the feed so that things look a little bit better. Okay, yeah, things are out of proportion. Okay, now we're good. Okay, so the new, let's start with the new features, because that's pretty cool stuff. Yeah, here is a notebook that that demonstrates Jananga 4.0. And this notebook is available on the Discord general channel. So I pinned the link to this notebook, and this one goes through and builds an example where you've got a school offering courses. So this is actually exactly the example that I pulled from the SQL documentation.
Mm-hmm.
But this gives us a nice place to start to talk about what we can now do with existential conditions. So we've got one course has been deleted, and so we want to find all of the courses in the school that were not deleted. So let me do a toString on this. That way we can see. Oh, I have to do a run all. There we go. That way we can see what it generates. And actually, it's already. I've already jumped to the end. Let's get all the way back to what this used to be. So. Okay, so we had this kind of a specification where we say I want the courses and facts of type course, where the course school is school, and then also this where clause where not deleted .any, and so that puts the existential condition in there. So one of the things that you could do before, so this part is not new, you could take this facts of type course, and you could put this lambda inside of the facts of type course and simplify things a little bit like that, which means now this whole thing could just be like that. So that's been possible for a while. What had not been possible was to put this lambda inside of any, but now you can do that. And so having a lambda inside of any is a LINQ supported syntax, but the LINQ processor didn't know what to do with that before. That was just an oversight. I hadn't created a test with that scenario, and so I didn't notice it was missing. But then got that fixed. But this is the really cool part. So you've already seen here that GitHub is Copilot is giving me some recommendations. when I was working on this, GitHub Copilot gave me this recommendation here, fax.any. Let's see if it'll do it again. Oh, that's an interesting way to do it. That's not exactly what it told me before, but yeah, right there. That's the recommendation it gave me before, and I was like, huh, that is a really cool recommendation. So that's a combination that you're going to end up using an awful lot in these negative existential conditions, and it just kind of collapses it down into one. So I made that syntax work.
Okay, it's even compacter than before.
Yeah. Yeah. So yeah, now you can just put the join in there. You've got your condition. You've got your negative. It expands it out, does the right thing, but that's all you need to write. And then the last part was, I'm kind of in the habit of having multiple where clauses. It's just a thing that I do, and so I never really thought to support this syntax. But other people are not crazy like me, so other people might want to be able to use and instead of just multiple where clauses. So that is now allowed, which means that combining all of these things, you can take this whole where clause here and you can put that in there. Well, so that simplifies that down. But now, of course, these this extra LINQ-like stuff out here is not very helpful. So now it can just be like this.
Yeah.
So I don't know if that makes it easier to read. It certainly makes it a lot less wordy. I guess it's easier to read. What I'm not sure about is it easier to learn?
It will be getting used. You will have to get used to it, I think.
Yeah.
And it looks less familiar because you lost the where clauses.
Mm-hmm. Yeah. So the the syntax is completely up to you as a developer, which has its upsides and its downsides. Upside, of course, is if you like the where clauses, you can use the where clauses. Downside is you're probably not working alone. Somebody else on your team is making decisions, and they might be different from your opinions.
I would, for the moment, stay personally with the where clauses, but just one will do.
Mm-hmm. Yeah, so like that.
Yeah. But the fact that both are supported, everybody can choose what he wants in that way.
Yeah.
But as you say, if you work with multiple people in the same office, then you have.
Mm-hmm. Yeah, that's. I hear that argument a lot from like when Microsoft releases a new version of C# and it's got some new language features, and people are upset about the language features that were added. You'll often hear arguments about, well, if you don't like that feature, you don't have to use it. And I'm like, nope, that's not the point. You work with other people. Those other people might use them. You do need to be able to read those new language features. So there is an argument against new language features because you would have to read them. But yeah, so yeah, I'd recognize that I am making more options for people to read, but the The problem here is that I'm building a DSL within a language that already exists. Of course, the C# language, but also the LINQ language,
Yeah.
and LINQ already has two syntaxes, um, and LINQ already has convenience methods. So this is just a convenience for for doing a .where.
Yeah, people might just expect it to work because it works in LINQ.
Yeah. Well, okay, got that backwards. Anyway, yeah, facts of type, yeah. Yeah, so if it works in going crazy. Yeah, if it's allowed in LINQ, then it should be allowed in Janaga. That's kind of curious why it doesn't like that. Oh, that's weird. Okay, it got confused, and then adding the parentheses straightened it out again. But all right, that's fine. that's valid as well. Yeah. Yeah. So yeah. As somebody who's already used to LINQ, you're going to approach these things, and you're going to write the LINQ that you're used to writing, and whatever that LINQ happens to be, it should work. It doesn't make sense for me to impose my preference on you and say, nope, you must write multiple where clauses. And yeah, that also opens up the possibility that you could write a very terse statement that just... Yeah, let's get back to the terse statement. Of course. So we've got course in school and facts of type deleted, and let's put this inside of an any here. So I do want to be able to... One more, yeah. Yeah, I do want to be able to allow people to write as terse syntax as possible, because once you get over the hump of understanding that that you've got a fact repository here, and this gives you access to all the facts, but you have to use it in very constrained ways. So you can just do facts of a certain type, and then you must have a join to something else. Or you can have facts of any, and you must have a join to something else. Once you learn those basic rules, then I think this syntax will start to become a pattern, where you can very quickly look for patterns like, okay, this is the deletion pattern. It's got a single negative existential condition. Great. And by the way, the pattern that did not work before was the nested existential conditions. So if I do a fact type here, and I say course restored, which I think I have a little bit later in the example, but it came up with the wrong. Let's see. I'm going to say course deleted. It is what I'm referring to. So now I can say, and not any course restored, joining that back to the course. Yeah, actually that does line up with that. Oh, that's where I... Oh, that's an interesting interesting consequence of this syntax, is that it's possible to misalign the parentheses in interesting ways. Interesting. So yeah, that's probably the most nicely formatted way of having this. So now you can pretty cleanly see this is the join for those facts. This is the join for that condition. And this is the join for that condition. Okay. That's why it came up with the wrong balance. Is I had it joined all the way back to the course. I went ahead and accepted that recommendation without reading it. But yeah, if you join back to deleted here, then you can't have the parentheses out here because it can't find where deleted is coming from. Okay, so maybe that's not so bad. Maybe that's yeah, but then that actually produces the correct nested existential condition now. Yep, so that's the new language feature.
And you saw that by accident when you were refactoring.
Yeah. Yeah, exactly. Yeah, let me show you the refactoring that I came up with. Let's see, what branch are we on? Yeah, we're on the main branch. Okay, good. So let's go to the LINQ processor. Yeah, so I got a little bit tired of seeing a whole bunch of mutation of the specification object inside of code that recognizes how to process LINQ expressions. So what I did was I took all of the mutation outside of all that messing with specifications, took that outside and put that into its own little thing called LINQ processor. I called it LINQ processor because of the names of the methods that I wanted to use, even though it's actually quite the opposite. This is not processing the LINQ. It's the thing that calls it that's processing the LINQ, but maybe I'll rename it. So if I take a look, I might not be able to get to it from here. Let me open this up in VS Code. I've got documentation for the LINQ provider. So yeah, I started this document in order to analyze what I needed to support, and then in so doing, got a pretty clear picture of what I wanted the code to look like. So these are all of the LINQ constructs that we can support. Yeah. So, and this is written in kind of a pseudo Bacchus-Naur format. So in order to produce a source, which is basically an IE queryable of T, we can do the facts of type with the predicate, where select many. This select many, by the way, the one that only takes 2 parameters, wasn't implemented before. It was only the one that has the result selector, and that's because I was so used to just writing LINQ with the keywords that I never actually wrote out a LINQ with a select many. This is the way that a programmer using extension methods would use select many, but this is the way that the LINQ compiler uses select many. So yeah, I only ran into that one. So yeah, that was another thing that I added. So these are the different ways you can produce an iQueryable of T. some of them take a source to start with, and I documented it where it's the source is passed in as the first parameter versus source.where predicate. So yeah, the way that you would see it as a as you're calling the extension method would be like this, but extension methods are just static methods that pass the first parameter in. So I wanted to document it that way, which also made it a little bit clearer what is happening first, because it's not the first thing that you see. The source is actually buried inside of a parameter. The first thing that you see is the last extension method that gets called.
Mm-hmm.
So these are the different ways to produce iQueryables, and then predicates. So I added the and, but we also had the not. We had the source, the any of source, and now I added the any source predicate. And our new friend, facts.any of t.
With a predicate behind. Yeah.
Yep. Yeah, that one has to have a predicate. I do not have a variation that does not take a predicate. And that is, there's really no reason that you would ever use it without a predicate, because the very next thing that you would have to do is .where in order to join that t to the rest of the query. So yeah, in neither syntax did it make sense to have any with no predicate. And then this is one I don't think we've talked about, but has been supported for a while, is that you can define a property of type condition on a fact, and that condition stores a specification. So let me do a little side tangent, and we can talk about condition. So here's the condition class. Its constructor takes an expression of function fact repository to Boolean. And let me show you some examples, like right here. So here's the office fact. Office is closed if there is a closure where office closure office is this.
Yeah.
So this can be greatly simplified. In fact, that would be kind of interesting. Let's see. Let's walk through this one. So now instead of that, we should be able to say facts.any office closure office equals this. There's nothing more. That's it.
That's a lot shorter.
Yeah. Which means that we can probably, yeah, it's already an expression-bodied property. So, yeah, I think that's as short as we can get it, which is pretty good. But yeah, by wrapping you're basically wrapping a new child specification, just the predicate part of it, inside of a condition. Then we can use this inside of a where clause. So yeah,
and that way it gets nicely structured as well.
Yeah. Yeah, you don't have to repeat those conditions all over the place, and you give it a name, and so now you can read the name. You know what it means. So that's what that one means. So and then left equal right, or left contains right. This is just to make .NET happy, because one of your predecessor references could be a collection, and so you want collection.contains. So that's just a predicate, which turns into the same thing as left equal right. It's just the LINQ happy way of doing it. And so then either left or right can be a label followed by dot roll, dot roll, dot roll, however many you want. So that's the syntax that we need to support. And then I started going through some examples and saying, okay, what parts of the syntax do those examples use? And this is where I was able to kind of break it out into a tree of these function calls. I mean, I put those in air quotes, but they literally are function calls. So yeah, this is basically walking this BNF language and building a tree and or grammar, I should say, building a tree, and then that tree means the same thing as this LINQ expression. So we should be able to turn this LINQ expression into a tree of function calls. And we get a little bit more complicated, and we've got a couple of where clauses, so nested where clauses. The first thing that you see here is the facts of type employee, but that's already nested within a couple of function calls. So the reason that is important is because when you're just looking at facts of type employee, you don't have enough information to put together a full specification. First of all, the specification that you would try to build would be invalid because there's no join to any givens. But then furthermore, you don't have a label for this type employee. You don't have a name for that label, at least. So by documenting that this is a function call, and we visit the function call before we visit the parameters, then this makes it a little bit clearer to us that we can look at the second parameter and take a look at its lambda argument. So this is actually that lambda. So we can say, okay, I'll use the name of that argument as the name of the label. And then we can return to the first parameter and dive into it and say, here's the name that I suggest.
Yeah.
So continuing all that, so not is its own function, takes a predicate. Any is its own function, takes a predicate. And all the way down to the more complicated ones. So when I finally got down to this one, what I wanted to do was to document how does this processor build a specification from the bottom up. And so what I wanted to do was document that in terms of the specification language, but relax it a little bit. So the specification language does not have to be, it doesn't have to retain correctness through the whole thing. So right here, we start with a specification that's not correct. It doesn't have any joins or any conditions inside of that match. So I'll say, okay, but I will allow it as I'm documenting this. This is similar to how I did the inverses. For inverses, you can pass through a place where your specifications are invalid. Compute the inverse, and then when you come back, you will end up with a valid specification. In the case of the inverse, I didn't need to revalidate it because I knew exactly the steps that the inverse was going to take, and those steps are guaranteed to give you a correct specification at the end. But in this case, I do need to validate this specification that comes out. So if the user were to just write facts of type employee, and this is what they get out, then there has to be some code to say, nope, that's invalid.
Yeah. And for the moment, it stops already, or it just crashes?
Yeah, actually, I do have that code in there to validate. So it throws an exception, and it tells you that you need a join.
Mm-hmm.
So so yeah, now you can start to see. Okay, source means that I'm going to return part of a specification. So I've got the collection of matches, and I've got the projection. I just don't have the givens. And in fact, there's nothing in here that tells you the givens. The givens are way out here, and the name that you give to these parameters. Right now we are just processing what's inside. So so yeah, we're going to just build it up, and then by the time we get to the outside, then we'll put the givens on it and do the full validation, make sure everything is hooked up. So, facts of type gives us back a really small specification minus givens, and then the next thing that that we see is the employee company equal employee. So this parameter here. So that's the next thing that we see on the original syntax, and we are, the very first thing that we call, the very first thing that we see when we're walking this tree is the last thing in the syntax, the select the outer function call.
Mm-hmm.
And then selecting from what, where, it's actually that where that we're seeing. And then this select many maps to that from. And then this where maps to this where. And then finally this one maps to the first from. So it's all inverted as we're walking down the tree. So so now when we see that construct, that is an example of a predicate. And so this produces a condition, that produces a condition, any produces a condition. Of course, that one produces a condition, and that's, that basically negates an existing condition. This right here, though, does not produce a single condition. So, predicate, the data type that it returns, is not just condition, but it's a collection of conditions. So this is an immutable array or immutable list of conditions that must all be true. So there's an implied intersection operator on that. So for most of these, they just return an array containing one condition. So that's why I've got this one documented like here. It returns that collection with just employee company equal company. And then now we are applying that where function call. We've got the specification from below, and we've got the condition from the second parameter, and now we put that condition into the specification. Then continuing on, we've got the facts of type manager, so that gives us another empty specification. And now we do a select many, and what select many has to be able to do is to concatenate, has to merge these two specifications. So it basically just takes all the matches from the source and all the matches from the second parameter, and it just unions those two sets together. Yeah, just concatenates them. Yeah. So that means this one does not yet have any conditions associated with it, because what happens here is it does that where, and then select many, it grabs the from, and it implicitly creates a structure that contains all of the visible labels. So both employee and manager pop out of that. So if you were to compile that LINQ, then these are the function calls you would get. So it would implicitly have a structure that contains both employee and manager. And it gives that some weird temporary name that you can't actually type into a C# code file. But yeah, it's just a string, so I put it in a symbol table, look it up, and I get back a thing that looks like that. So that's okay. It just I just take that result selector and I turn that into a projection, and then I've got all the matches. Just concatenate those together, and then we finally see a condition. So it does the where on those things. And so now the trick is that I have to find where that condition belongs inside of this specification. And this is actually where the bug was hiding. I was making an assumption about where the condition belongs. And so in this syntax, I ended up accidentally putting it in the right place. In the nested existential condition, I didn't put it into the nested any. I put it one level higher, and it just ended up in the wrong place, completely confused everything. So so the way that I'm doing this is I'm taking a look at the base of the left-hand side and the right-hand side. So we've got manager, we've got employee, and I look for the last match that uses either one of those two labels. And I say, okay, you belong there. So in this case, joining employee to company, I was just looking through the collection that had only employee in it, and I said, okay, the last one that has either employee or company is employee. I'm not even worried about the fact that I don't know what company is while I'm building this up. Eventually, I'll figure out that company is a given.
Yeah.
So then, continuing on, we finally have a select that pulls out just the manager, and so that basically allows me to replace the projection. And so, going through this analysis, I was then able to figure out what does each one of those functions do, and then write them all from the bottom up, fix the bug along the way, and then replace their all of that weird logic with just calls to those functions.
So now we have nice documentation.
Yes, nice side effect too.
That's not an unwanted side effect. Yeah.
Yep. So then I also have some tests for this. So
that documentation is also in the repository?
Yes, it is.
And the first one where you put the link to on Discord?
Yeah, that's in the repository as well. So the examples folder has school IPYNB, and then documentation has link provider MD.
Okay.
Yeah, and I was able to build this up by making these function calls. So it's like, yeah, let's get to some really interesting ones. So, like here. Yeah, look for the employees where there are not any terminated. Here where I'm comparing, so that's the left equal right. Terminated employee to employee. And it generates that little bitty specification. Yeah, so what it's actually producing is a collection of matches, not a full specification, but just a list of matches and a projection.
Okay.
And one of the neat things that kind of came out of this is, before I was trying to to think about the iQueryableness of things, while it was also thinking about what symbols go into the symbol table. But as it turns out, every time you introduce a new symbol, it's in a lambda like this, where that's probably not the, yeah, like this one here. You're introducing the symbol office. That's implicitly the parameter of a lambda that would go inside of the where. So you could either have the lambda there, you could have the lambda inside of the where, but either case, it'll be the symbol office. When you're introducing it, it's not the iQueryable of office, it is office. So the symbols that go into the symbol table are never the collections. So my symbol table used to be, far too complicated, and then I realized, okay, I don't need all that complication. While it's going through and building up these specifications, that's keeping track of the collections and how those collections are constrained. Then the only thing that ends up inside of the symbol table are the projections. How do I get things out of those collections?
Yeah.
So that simplified things a great deal. Like select. All select does is replaces the projection. So you've got your source, you've got your selector, it just replaces the projection with a new one. That's it. Keeps the exact same set of matches as the source. Because .select in LINQ is not going to change the number of rows that you get out of the LINQ statement. It's just going to transform each one of them. So change the projection. That's it. So that ended up pretty nice, I thought.
Indeed, that's step by step. The specifications are going in a very powerful direction.
Yep. Yeah, I think so.
It's good stuff.
Excellent.
And you're going much faster than I'm going on my side. Luckily, we would be nowhere.
Yeah. But yeah, I think I will return a little bit to the replicator as a service, do some work there. What I want to get to is the point at which you can add an authentication card to a replicator. So so right now the replicator just has that one card which tells you what your URL is, but I want you to be able to add cards. So okay, I want to add replicator or add authenticate using Apple ID. And then it'll give you like a link to some instructions how to set up that stuff on Apple's site. And then here's the data that you need to provide, like the callback URL. So the replicator as a service will serve as the callback for authentication. And then it says, okay, after you follow those instructions, you'll need some some of the outputs, like the private key for decrypting the payload. So Apple generates a private key when you set that all up, and then you take that file and upload that into replicator as a service, and then that's stored as part of that replicator. And now you've got your little key store, and you support sign in with Apple.
And that can be used for authentication.
Yep. That's the goal.
And for encrypting the messages.
That gets you the first step of the way. So I don't yet have message encryption built into the system. That is going to be some extra syntax that you'll need to layer on top of. This fact is encrypted using that shared key. this shared key is inside of a fact is it's shared with that user. So so each time you get a shared key, it's encrypted using that user's public key. So yeah, those ways of building up encrypted facts, those are not yet implemented in JavaScript or in .NET.
Because I don't remember the details, but there were quite a lot of restrictions on that.
Yeah.
Because you have to all the links to predecessors, they cannot be encrypted, otherwise you lose the structure.
Right. Yeah. Exactly.
And then also to share, you wanted to work with keys that expired after a time, if I remember well.
Let's see. I don't recall putting any kind of expiry into the model, but you know what? That is something that we need to consider for sure.
Why was that? Because if you have to, one of the problems was when people, if you delete people, or you want them not to have access anymore.
Oh, okay, yeah.
Yeah, I don't remember exactly what it was, but
yeah. Yeah, the problem is that deletion or revoking access, this whole revocation pattern, revocation cannot be based only on predecessors. It has to be based on successors, which means that you might get revocation in some places but not others. So you can't prove eventual consistency of revocation. So if somebody's access has been revoked, but they haven't learned about the revocation before they created a fact, they think that fact is valid, and then by the time it reaches you, you think it's invalid, and you get inconsistency. Yeah.
Yeah.
Yeah, which is it's a real problem out there in the world. This is just the math making that problem visible. Just describing that problem, but it's the math offers no solution to the problem. It just says it's unsolvable. You figure out what to do with it. And so I basically want to build up one function at a time in order to get to that point in Replicator as a Service. So start with authentication, and then next I'll do authorization rules. So you should be able to write your authorization rules in JavaScript or in .NET, and then run a command line tool to upload those rules to the Replicator as a Service.
Yeah.
And then you make that part of your CI/CD build.
Mm-hmm. That would be great.
Yep, and that'll get Replicator as a Service up to the level that you can currently do by hand. But the thing that you cannot do by hand right now is distribution rules. So then I'll need to come back to, okay, how do you implement distribution rules in JavaScript and in .NET? Make those work. I'll just have to work on the JavaScript because we don't have a .NET server yet, and distribution rules are strictly a server-side concern. So yeah, I'll implement those in Janaga.js, and then I will port those to Replicator as a Service.
Still a lot of work to be done.
Yes.
I count on you, Michael.
Yeah, but once we have authentication, authorization, and distribution, that is the minimum viable product to say, okay, it is ready for production. It doesn't require encryption in order to be a viable mobile backend as a service. So if the replicator will distribute to your mobile app, then you are allowed to see it, and your mobile app isn't going to be decrypting it. Yeah. The reason that encryption becomes important is when you start to connect replicators together, and you want to be able to pass through an untrusted replicator in order to get your information someplace else. So
Yeah.
have it be encrypted while it's in this other replicator, and then you can decrypt it on the other
Mhm.
side.
Yeah, but for the moment,
Mm-hmm.
that's when the whole world comes together, all the replicators in one.
Yes.
Um,
Yes. And then people look back and say, why haven't we been doing this the whole time? This is so much easier.
yeah. Uh, Sometimes afterwards you say that that's so easy,
Uh-huh.
so obvious
Yeah.
after the thinking, but
Mm-hmm.
to come up with the idea, it's because already where you are now. Um, I remember when you started, it's an incredible way that you went.
Mm-hmm.
Um,
Yeah. 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 Before I was really just trying to derive meaning from a graph.
mm,
And it's like, okay, let's just figure out how to do that. And then yeah, where it ended up now and where it's going, it's like not only can we derive meaning from a graph, we can connect these graphs together, and they behave in the way that you would want them to, and
mm.
it's amazing.
Yeah, but also the way it was implemented. If you look back to the Pluralsight courses,
Oh yeah.
and where the implementation of the structure was really inside the C# code.
Yeah.
Um, the facts were literally in the structure of the program.
Yeah.
Um, while now it's completely independent.
Yeah. Yeah. Exactly. Yeah. So. Uh, yeah, it used to be that you had to know how to implement these patterns, and now,
Mm,
um, yeah, you just have to understand what the promises are, uh, and then they will, the library will generate the behavior to fulfill those promises.
mm. It becomes more and more just like in a normal database. No,
Uh-huh.
but the way you use it is like you use SQL.
Mm-hmm.
Um, while with Pluralsight at the beginning,
Yeah.
um, you really had to do a lot of programming to get every screen updated.
Yeah.
It was one big spaghetti, while now it is
Mm-hmm.
really concerns which are separated.
Yeah.
Mm,
Yeah. I'm looking forward to testing that, to actually,
mm,
getting a team of developers that are all skilled in building screens using Janaga and say, okay, you work on that screen, you work on that screen. Hey, but when I do this, it affects his screen.
mm.
It'll happen. Don't worry about it. Just boom, boom. Hey, they
Yeah.
integrate.
Or this is not yet working the way it should be, or that's not implemented, or that's
Yeah.
too difficult. Yeah.
Yeah, and it's like, okay, that's not a problem. You don't need to have this admin screen to set up your catalog in order to do the shopping screen. We'll just go
Mm,
into the replicator, and we'll post some facts into it, and then
mm,
or go into a notebook and just create a whole bunch of facts. Do a weight
mm,
fact inside of a notebook, and we can render the graph and see, okay, yep, those facts are there, and then they're in the replicator, and you can start to write
mm,
your shopping cart against it without even having a way for a regular human to put stuff into the catalog.
mhm. Good. I will see to finish that little thing. Tomorrow I'm not there. The weekend I'm not there, so that starts already bad. Um, but perhaps if Monday nothing urgent is coming in, uh, or perhaps I still have a little bit time before my wife comes in. I say, okay,
All
Michael,
right.
thank you very much, and see you next week.
Thank you. Yeah. Yes, I will see you then.
See you. Bye
All
bye.
right. Bye.